Welcome. Today we're diving into predicate logic to understand its complexity and its powerful expressive capacity. Let's explore. Predicate logic empowers us to express complex relationships through predicates, variables, quantifiers, and functions. Think of the statement, a Tesla Model 3 exists, which is electric. Here, car, electric, and make model are predicates relating to the variable x. The yeah quantifier indicates at least one such entity exists. Tesla and Model 3 represent specific function symbols. Thus, our topic of interest allows us to go beyond propositional logic, detailing relationships and nuances. Today's spotlight is on quantifiers in logic, primarily universal and existential. Universal quantifier, signified as for all, suggests that every Toyota car is electric. On the flip side, the existential quantifier, represented as there exists, designates the presence of at least one hybrid vehicle. Additionally, intricate conditions are represented by interconnecting these quantifiers, like asserting every manufacturer produces at least one eco-friendly model. In environmental analysis, for all x, E of x implies there exists y, such that f of x, y means every electric car has a unique environmental feature. Moving on, for all x, Cx and not Ex implies h of x asserts non-electric cars have higher CO2 emissions. Finally, there exists x for all y, dxy conveys there's a city where all cars are electric. Here for all is every, there exists is at least one, implies is if then, and combines conditions, not is the opposite. Deciphering these statements helps us understand the environmental impacts of different types of vehicles. Function symbols such as submodel and battery capacity enrich categorization in predicate logic. Take, for instance, the symbol submodel denotes a car's model or performance, while battery capacity indicates a car's battery capacity, say 100 kilowatt-hours. These symbols aren't just categorizing attributes, they enhance expressivity, from denoting a car as simply electric to identifying its distinct charging technology like supercharger. Picture these predicates as identifiers, progressing from basic categories like electric to incorporating detailed features as submodel and battery capacity. Thus, we create a complex map of details within broader categories, enhancing the intricacy and richness of our logic system. This slide shows how we use predicate logic to understand the environmental effects of different kinds of cars. When we say, all cars that use fuel result in high CO2 emissions, we're using a logical formula to make a statement about the real world. By contrast, all electric cars emit significantly less CO2, another statement made possible by logic. If we glance at the table, we can see these two propositions laid out clearly, connecting car types with their respective CO2 emission logic. This matchup reinforces the environmental impact of our choice of cars. Our exploration today involves quantifiers in urban electric vehicle, or EV policy. Recall that predicate logic uses for all and exists to structure propositions. Examining the case for all cities, there exists a specific electric car model. It points to diversified EV models throughout cities. Conversely, there exists a universal electric car model for all cities, denotes the availability of a standardized model in every city. Glancing at the table, the sequence can distinguish a broad policy, aiming for diverse EVs in every city, from a focused one, pushing for certain models to be universal. Applying predicate logic to auto policy and planning invites interesting insights. This first equation articulates, for all cars represented by X, it implies a certain type of emission, implying a classification based on emission types. The second equation reads, there exists a car X that is either electric or hybrid, expanding our vehicle classification system. The third equation suggests, for all electric vehicles represented by X, there's an optimal charging station location and count, fostering effective EV infrastructure planning. Cumulatively, these statements underscore how predicate logic can revolutionize diverse areas, from emission differentiation to classification improvements and optimal EV infrastructure planning.